Hi, everyone. Welcome to the next installment of Navability's videos. Welcome to our YouTube channel. Today, we wanted to tell you a little bit more about the robotics journey for everyone that's building robotics or wants to get involved with robotics. There's this sort of question mark about, well, how do you make a fancy robot work, or maybe a very specific robot that does a job? How do you go from, oh, I have the idea, through all the steps to make the hardware and the software and the sensors all work together? We at Navability sort of have a thought of how to do that. So we actually wrote a blog post on it, and the four of us are here together. Sam is with us, and Jim and Johan, and this is one of our first virtual recordings. So we're going to just show you the blog post and then show you some of the animations and talk through it and have a conversation. So Sam, could you maybe just open up the blog post just so people know where to find?
I'm going to go straight to screen share so you can see my screen.
Oh, yeah. Absolutely.
All right. So this is our last big blog post. And we go deep, right? Effectively, what we wanted to do was plot out the roadmap that you as a user would go through, building out a robotic solution, because it sounds like a fun and interesting thing to do. And you very quickly go down a rabbit hole and very quickly end up in a couple of pitfalls, which I think we spoke about a little bit here. So this is an opportunity. We put the whole map here, but this is an opportunity to maybe talk through this a little bit and use this as kind of context for future videos. You can download the whole map and go read the article too, but for ease of use, for digestibility, we thought we'd talk through this, make it a bit of a conversation.
All right. Absolutely. So Sam has prepared for us an animation, and I think let's take it away, Sam. Let's have a look.
So robotics idea, right? Where all good things start with an animation, because the one MBA in the room definitely wants to put some slides together. You're sitting in a room, you've been given a project that's let's build a robotic system. And on the right, the system we've put together is, maybe it's a robot that has to walk up to a table, give something to an arm, and the arm has to do some packaging and put it on a car. And the car ideally maybe has to drive off automatically and go deliver it. This is a pretty straightforward use case. I'm sure there's a few people out there that are thinking about this. So this isn't just something new, but it's definitely ubiquitous, right? This is your idea. Maybe Monday you come into work and someone says to you, let's do this. We want to take over the logistics industry. Right? How do you start this project? How do you, get off the ground? And how do you end up knowing that what you deliver will work and will match this initial picture in the beginning? Step one, right? Just choose the hardware that we're going to use. That's the easy part.
It's the easy part?
Yeah, maybe it's not the easy part. Why is it not the easy part?
Well, it depends. Do you have hardware? Do you need to still build the hardware? Are you trying to decide? I suspect a lot of projects will have some hardware ready to go and you sort of want to test it. Maybe you'll add a sensor or retrofit a little bit. How did you do it, Johan?
That's definitely not the easy part. It depends very much on your accuracies you want and what you want to do. And by the time you pick it and everything, you realize it might not have been the best choice, and you have to adapt and write drivers, and it's a hard thing to get correct.
When do you find out it might not be the best choice? Because you have to pick the hardware early, right? When do you find out you're in trouble?
Probably too late most of the times. When a thing wants to drive into a wall or something.
So that's part of the good discussion. I think maybe we should go in a little bit more depth over there at some point, right? Hardware choice impacts you much further down the line, and it seems like you can just buy a bunch of hardware and integrate it. But I would hazard that the majority of people that do get bit in the butt.
Yeah, and my understanding is when you choose hardware, you're not just choosing hardware, because it's always like you're choosing the integrations that you need, the sensors that you need. You're basically choosing the entire system at this stage, because most hardware has limited support, right? It can only do some things, and you're not sure what things you actually need. So your step one is not necessarily just choosing hardware. It's like choosing everything in a lot of cases, depending on what hardware you pick.
That's a good point. So let's go to step 2. Aha, choosing sensors, right? Good segue, I appreciate that. So we have about 8 minutes. We don't want to shoot over here, but exactly that, right? Sometimes your hardware chooses your sensors for you. Sometimes you have to, weld and Frankenstein sensors onto your equipment. Sometimes you have no idea what sensors you need. Sometimes your software chooses your sensors for you, right? And that was some things get very interesting, because maybe I have a software stack that I want to use, and I know it needs a LiDAR, right? And I can't use anything but a LiDAR. So then I have to pick hardware and sensors based upon my software, which is a really weird place to be. But this happens, right? Correct, Dehann?
Yeah. So in my experience, you inherit some bit of robot with some sensors on it, but then it's not quite the ones you want. Then you go and order the new one, right? I want the new LiDAR, but it's not in stock. So you can't wait 3 months, so you start developing. So somewhere down the road, you have to change the sensor. So, the flux of what you thought you were going to use as your sensor, where you end up in 6 months, or when you're doing your demo, there's flux. It's not all stable, especially not in the early R&D sort of phase. So you choose sensors, and then you eventually end up with a slightly different set. That's my experience.
That's great.
The cost has been a big issue, because the sensors you actually need, if you evaluate the sensor on its own, is way too expensive for what you need. But if you can combine the sensors in a certain way, then you can reduce the sensor accuracies that you need as well. Have you done that before, Dehann?
Absolutely. Right. It's 80% of the performance comes at 20% of the cost. But if you want let's say you want a gyroscope that's got this really high performance, it just gets so expensive. So you kind of want to maybe mix it with a camera or something, or a LiDAR. So I definitely think that mixing 2 or 3 sensor types together will do more robust and better localization and mapping. But you have to deal with the software. You have to process it somehow.
Oh, so yeah, in the interest of time, this is a great discussion. We can easily go on a rabbit hole. This is the intention, right? Set ourselves up for some great rabbit holes in the future. So you just mentioned an important one. Why am I putting sensors and robots on a platform? Because I have this idea, right? I want to deliver boxes, right? And why am I doing that? Well, hopefully our earlier videos should help you remember this picture, right? Because what do I want to do?
Integrate data, right? I mean, there's gathering data doesn't do anything. You want to be able to use that data to actually understand or do something, right?
Mm-hmm. You want even further. You want to action the data, right? Right. Why do I care about navigating my robot? I don't really, because the robot has a job to do. The point, though, is that getting the robot to do the job, you need the navigation piece in the middle, but it's often forgotten or missed.
Mm-hmm. Exactly. So step 3, let's put the sensors together to start pulling information out so we can build a map, which is step 4. Mm-hmm. And I need a map
of the environment. I think we should be clear, right? Like, if you show up in a place you've never been, you suddenly understand the room around you and you can find the door and walk through the door. Making a robot or a digital system or a computational system do that, it's hard. So you need to know where it is, and you need to know the map. Landmarks, one of those.
No, precisely. You want a map and then use parts of the world to understand where you are. And that's to build a map of your environment. And Jim gave a beautiful example of, I see a room, right? How does it work? I close my eyes.
Yeah, if you close your eyes and walk in a circle, how do you know you're back to where you started? Well, you open your eyes and you look at the door, and you know that the door was where it was before. Or you run into the wall. You got to hit something or see something that you know. And that's what we call a landmark.
Yes. So I build a map and then I want to integrate it so I can find these errors, right? So that I can fix these errors so that when I open my eyes or my robot opens its eyes, it can be like, one step to the right, one step to the left, a little bit of cha-cha, and then I'm back where I started, right?
Yeah. And this applies to sonar, radar, camera, LiDAR. So landmark here, we're using sort of as a loose term for different, all kinds of measurement, right?
Mm-hmm.
One of the hard things here is what do you do if your landmarks move?
Oh, even better, dynamic, contradictory, and prior data. Oh, that's a beautiful example. I know that you had this great example in the construction industry. So you're setting me up over here, which is fantastic because I know you haven't seen these slides yet. So this is really
Yeah,
good.
that was surprising.
That was well done. Okay, so
Yeah.
in the interest of time, we've got 3 minutes. Now that gets you a map of the world, right? Now, how do you handle this imperfect data? Well, come visit us at, ICRA 2022 on May 27th, and we'll give you examples of this, tangible examples of handling contradictory data. And you have to do all of these things to get your journey working. Because once you've been able to do that and build this map, tonight my robot goes to sleep, tomorrow it wakes up, what does it want to do?
Yeah.
It's the same thing it did yesterday.
Do more, do something new. It's the same thing and do new. And an important point of the contradictory stuff is what if you have some prior information, like the robot's going into an area for the first time, I want to give it some prior data, but now the prior data doesn't quite fit, right? So tomorrow you want to explore more. If it's a construction site, you want to sort of not only track how the progress is going and all the changes, but what are the discrepancies between your prior data and what's actually happening. That's where the real value is at. So yeah, definitely invite you to come have a look at some of our stuff on that.
Mm-hmm. So adding memory, right? Mm-hmm. Yesterday I saw some contradictions. Let's go look at them again today, and I can use that information. I want the memory. You mentioned contradictory and you mentioned prior data. Exactly. Next thing in the journey, right? How do I put a CAD model in to be like, I know what this room should look like. Let's talk about this. We want to go in depth over here. A lot more detail. But we have 30 more seconds. So step 7, but we're going to get to the end of the journey. Step 8, now I've got walls, right? Now I want multiple robots to work together because I have to bring a box to the robot and the robot has to bring a box to the car or to the vehicle. How do I put that data into the wall? And then it gets really exciting. Now I have multiple walls, multiple robots and multiple maps, right?
That goes back to the static robot. How does one robot share information with other robots? So Alice sees the coffee cup and Bob's trying to find it, right? And we think a lot about how to do that.
Definitely, because I need that for the two robots to interact, and that's cooperative robotics. All the way so I can get to my final example. So my stakeholders / shareholders / manager, whoever's funding my project that wants me to build this is going to be happy. So we will go into this in a lot more detail. Any closing notes before we call this a wrap and then dive into these topics, hopefully in the next weeks?
All I'll say is that there's so much to see, and it's what we're trying to do is invite everyone to come find the different parts, or reach out, connect to us, or connect with us. We have a Slack channel, info@navability.io. Find us, and then at ICRA, as Sam said. So that's me.
Yeah, come join the journey. Let us help you with the journey.
Yes, I like that. Great. Well, that's a wrap. Like and subscribe. We will do a post on each of these topics in so much depth in the next coming weeks. But hopefully this is a roadmap, and go read the blog post if you want this original picture. Thank you. Have a good one.
Thank you.